And although we've already talked about these a little bit, we're going to look more in depth on characteristics 2 and 3, which is whether you have horizontal asymptotes or oblique asymptotes. Okay? Now, the textbook goes into an overcomplicated explanation. You can keep the simplified explanation. The simplified explanation, hey, which group is this? This group is where the degree is bigger on the bottom. If it's bigger on the bottom, I don't mind if you directly say, I know there's a horizontal asymptote at y equals 0. The textbook says, hey, if you went to really big numbers, so they have infinity here for x, what would happen? Can you see the bottom would be huge? And you take any number on the top and divide it by a huge number, you're going to get really close to 0. So that's what they talk about. Okay? So in this graph, what would it look like? You have a non-permissible value at -4 that doesn't go away, and we would also have a horizontal asymptote at y equals 0. And we could do the rest of the steps and find nice points and solve this one. Okay. Next, what happens if you have group 2, right? And again, I don't mind if you go right away to the shortcut. Yes. So you have the same degree on the top and the bottom. You have a horizontal asymptote at y equals 2. We've done some synthetic division here to explain it. You know what? That's great, but you don't need to worry about that. Okay. So in this one, if you graphed it, it's easy to see that the non-permissible value is at x equals 1. And now we have a horizontal asymptote at y equals 2. If we found our intercepts and some nice points, you would be able to graph that. But what is new is what happens when you have group 1 and the non-permissible value doesn't simplify to be a whole, as in this case. Oblique asymptote and you have to use synthetic division or long division. How does it work? You actually divide x squared by x plus 1. How do I write that out with synthetic division? Well, x squared would be a 1, and then you have to remember the 2 zeros because the x is missing and the constant's missing. And then if you were dividing by x plus 1, remember we put the opposite side out in front. We bring down the 1. -1 times 1 is -1. Add -1, and then -1 times -1 is 1. Add and 1. And this would be the remainder. And this is the quotient. Your quotient is your oblique asymptote. And the remainder you can ignore completely. Because when x is really, really big, having a tiny little bit extra really doesn't matter. That's why we can ignore the remainder. Again, they go through an extra complicated explanation. All you need to know is that if you want to have your oblique asymptote, you do your synthetic division. Whatever your answer is, ignore the remainder. X minus 1 will be your oblique asymptote. Highlight that too in your notes if you like. Oblique asymptote is a diagonal oblique line. Well, I wish they would have drawn this graph for us, but I guess. Do you have it in yours? Yeah, you do. Where? There's a button. There's probably a button. Come on. So on your graph, it shows up have the graph in your notes. And you could label that diagonal line as y equals x minus 1. Notice that you still have a vertical asymptote at x equals negative 1 because that non-permissible value didn't go away. Okay, so we're ready for example 2. We've got our steps still listed there from before. And we're going to start off with part A. I'm going to factor it completely. This factors to x plus 7, x minus 1 over x plus 2. And although the question just asked about horizontal and oblique asymptotes, we are going to graph it completely using the steps. So with the steps, step 1, factor completely, list our non-permissible values. X can't equal negative 2. And we have to decide if this non-permissible value is going to be a whole or a vertical asymptote. Does it simplify? No. Because it doesn't simplify. And remember, when you write your vertical asymptote, there is an equal sign, x equals 2. So we have a vertical asymptote. Step 2 is done. Step 3. Which group is this? This degree is bigger on the top, right? So this is the one that has no horizontal asymptotes. And because we don't have a whole, we have an oblique asymptote. So we're going to have an oblique asymptote at y equals, and how do I find it? I find it with synthetic division. So I set up my synthetic division. I have x squared plus 6x minus 7, no zeros necessary. I'm dividing by x plus 2, so I put a minus 2 out in front. Bring down the 1. Multiply and add. Multiply and add. And even though the remainder is like quite a big number, minus 15, you can ignore it. Your asymptote is just going to be at x plus 4. I usually start graphing once I've got my asymptotes done. So I know there's an asymptote at x equals 2, and I also know that there's an asymptote at y equals x plus 4. So if I'm graphing y equals x plus 4, I would know that there's a y-intercept of 4. Yes?
With the vertical asymptote be at -2.
Yes. Thank you for noticing that. I wrote -2 there, and then math does this to you. You start thinking about the next step, and it's so easy to forget a little thing. Now, when I'm doing a question, I try to check things multiple times while I'm doing it. And I probably would have noticed something is going wrong later on in this question. Something's not right. But at this point, I didn't notice it. Thank you for noticing. So x equals -2 is our vertical asymptote. And with x plus 4, that has a slope of 1, which means you can go over 1, up 1, or over 1, down 1, or maybe you find the x-intercept at -4. However you like to draw straight lines, that is your oblique asymptote. So that's step 3. We've drawn our asymptotes. Now we need to find some nice points in our intercepts. Again, it's always easiest to start with your y-intercept. Again, there's where I would go to my original equation. Because you see if you put zeros in for x's, everything would go away except for the -7 and the 2. -7 over 2, you can write it either as a fraction or as a decimal. I would get 0, -3.5. I'm going to label that point 0, -3.5. X-intercepts, a little bit trickier, but not bad, especially if you've already factored, which we have. we had x plus 7, x minus 1 over x plus 2. And again, you can multiply both sides by x plus 2 to get rid of it. You're really solving where is the top equal to 0. And the top is equal to 0 at negative 7 and at 1. So I go on my graph, I can label it 1, 0. And negative 7, 4, 5, 6, 7. And we ask ourselves, do I need any other nice points? Well, I take my vertical asymptote. This will be section 1, and this will be section 2. The oblique asymptote doesn't make a new section. It's just sections by your vertical asymptote splitting it up. That's how your domain is split up. Do I have a point already labeled in section 1? I do. So this is enough for me to say, I need to go towards this asymptote. Well, okay. It shouldn't be bent like that. It would be like, try to make it smooth, and I lose a half a mark, I lose an E10 error here. You see how I swung away from my asymptote? I lose me a mark there, a half mark. It's really kind of an awkward one. Towards both of those asymptotes. That's that section. Weird. What does the other section look like? Well, you're going to join these 2 points, and then you're going to go towards those asymptotes again. This is your final graph. We didn't need any other nice points, because we had a point in section 1, and we had 2 points already in section 2. You'll find the ones with the oblique asymptote, that the graphs are usually in opposite, like if we cross our asymptotes here, they're either in this section and this section, or in this section and this section. They're sort of in opposite little corners. And this section on the left was really wide already. It was kind of awkward looking. But it would go towards both of those asymptotes. Okay, part B. Okay, that was our first ever one with an oblique asymptote, so now we know how to do that. Part B has, in factored form, it's exactly the same, so we already know how to factor it, except it's been flipped. So now we have more non-permissible values. X can't equal negative 7, and x can't equal 1. And we have to decide if those non-permissible values are holes or vertical asymptotes. And since they don't cancel out, well, I was really careful this time, and I remembered my name. So we have vertical asymptote at x equals negative 7 and x equals negative 1. Can you see that you have the situation now that your degree is bigger in your denominator? Whenever the degree is bigger on the bottom, your horizontal asymptote is the easiest one. It's just at 0. Degree is bigger on the bottom. It's going to be more powerful on the bottom when x gets really, really big. So that means you're going to be dividing by a huge number on the bottom. And that means you have a horizontal asymptote at y equals 0. I'm going to start graphing this. So, negative 7. And at 1. And at y equals 0. Step 4, we're going to find our intercepts. Again, the y-intercept is always the easiest to find. I would go to my original equation, scroll up so I can see it. If I plug in 0 for x, I have a 2 on the top and negative 7 on the bottom. I get 2 over -7 0, comma, -2 over 7. X-intercept. If I plug in 0 for y and I write out my factored form, which had x plus 2 on the top, and x plus 7, x minus 1 on the bottom, again, I can multiply to get rid of that bottom. I'm really only trying to find when is the numerator equal to 0. And in this case, it's pretty easy to see. I'm going to have an x-intercept at -2 comma 0. So now this feels a little bit weird. That's okay. Oh, I did it wrong again. -2 is bugging me today. Just erase. -2 comma 0 is right there. And that feels a little weird because it's on an asymptote. But once again, you can have graphs go through horizontal asymptotes in the middle. Horizontal asymptotes don't represent non-permissible values. They just represent what happens at extremes. We'll finish up this graph tomorrow.